All right, welcome to our next lesson video for Unit 2. Today in Unit 2, Day 2, we're going to be talking about algebraic proof. Okay, we'll talk about algebraic proof, meaning proofs or proving statements using algebra. So first of all, we want to talk about properties of equality. So you should be on this page of your notes, properties of equality. Make sure you write Unit 2, Day 2, algebraic proof at the top. If at any point the video is going too quickly and you need some extra time to write things down, go ahead and pause the video and we will proceed from there. All right, let's get started with some basic information about properties of equality. There's a bunch of properties of equality here, and these are the properties that allow you to be able to solve equations. What you do to one side, you do to the other side of the equation. That's the basic principle. So we're going to jot these down. You probably have seen them before, but we're going to recover them. So I'm going to show you all of this filled out here in just a moment. It'll transition over and show you how they're all filled in, and then I will show you and talk about what each one means. All right, first of all is what we call our addition property of equality. Okay, that is abbreviated as ADD, P-O-E. All right, that says if we have an equation, A equals B, then by adding C to both sides, it retains that same equal value. You can add C to both sides. Subtraction property of equality works very similar. We call that the subtraction, S-U-B-T-R, period, P-O-E, property of equality. Okay. A minus C equals B minus C. If we have an equation, we can subtract the same value from both sides. Same thing for multiplication property of equality. You can multiply by the same thing on both sides. And division property of equality. If we have an equation, we can divide by the same value on both sides. You guys are familiar with the distributive property. Distributive property allows you to multiply one number by a sum or difference. Substitution property, these is where some of these will be a little new to you. So the substitution property states, in an equation, if A equals B, then A may be replaced by B in any expression or equation. And then these last three are very important properties. They will carry through many different topics. We have reflexive, symmetric, and transitive properties, in this case of equality. Okay, these are POEs, property of equality. All right. First of all, the reflexive property, it's very simple. For any real number, A equals A. A value always will equal itself. There's not a lot to think about there. There's no tricks. A equals A. You will discover later on why we need to state this, but for now, just remember reflexive, A equals itself. Symmetric property is where if I have an equation written in one direction, if I turn it around, then it's also true. So if A equals B, then B has to equal A. And then the transitive property. This will be one of the most useful properties that we use. If I have two equations, if I know that A equals B, and I know that B equals C, then I could say that A equals C, because they're both equal to the same value B. Okay. Substitution and transitive are sometimes used interchangeably, but not always, so listen carefully for when I use those. All right, the whole idea today is that we are using these properties of equality to write proofs. This is a new idea for you. It's called a two-column proof. A two-column proof is any proof that is going to be set up in two columns to help you make statements and justify your statements with reasons. And so let's talk about this. Okay, two-column proof is a common format used to organize a proof. A proof is a way of writing a mathematical argument to get from a given hypothesis to a natural conclusion. Okay, and so we are going to organize these. So the left side is where we write our statements, or the steps of our proof. And the right side is where we list the reasons for each step. So not only do you have to solve the equation and show your work, you also have to give a reason for each of those statements. Okay, and there's a lot of different things you could use for reasons. Any of these properties that we've just looked at, or other various properties, can be used as reasons in a proof. Or definitions of these geometric ideas. things like supplementary, complementary. The definitions can be used in proofs. And then we're going to look later on at things called postulates. Sorry, forgot how to spell for a moment. And theorems. You guys know of only one theorem right now. You guys have heard the Pythagorean theorem many times. But we're going to learn a whole lot more theorems this year. Now, theorems are mathematical statements or geometric statements based on other postulates or theorems. We'll talk more about those later on. For right now, we're using properties to justify these steps. All right, so we're going to do an example or two together, and you'll do some on your own before you come to class, and we'll check those answers together. Okay, first of all, we are given this equation. All right, you will always be given two statements. You'll be given the given statement and then the statement they're asking you to prove. Okay, so we're starting with this equation. We want to not just solve the equation. They've given you the solution. We're told to prove that that is the solution by following the correct mathematical steps. All right, so hang with me here. We're going to always start as having our first statement being the given statement. In this case, we're just going to rewrite that equation as our first statement. So you notice I've given you these two columns here. The reason for the first statement is always that it is given. Okay? The reason for the first statement is always that it is the given statement. So we can always fill in that second blank over there with the word given. Now, we are going to look at how this work has been done. Notice they've done all the work for you. So we're going to look at how we get from here to here. The reason always explains how this statement was achieved from the given, not what you're going to do next. So the first statement is this, and then they give you 4x equals 28. Well, let's think about it. How did we go from this equation to this equation? You should notice that there's no more minus 1 on this side, and that this side is 1 more. That's because we add 1 to both sides. You guys would recognize that's the first step. By adding 1 to both sides, I get this. Since I added the same value to both sides, I use the addition property of equality, and that will be my reason. So our reason here is addition property of equality, and that's your abbreviation. All right? And then they go from this statement to this statement. Well, how do we go from 4x equals 28 to just x equals 7? You guys will probably notice that you would divide both sides by 4 to get this result. Since you're dividing both sides by the same value, we're using the division property of equality. And we have arrived at the statement we were told to prove. So we are done with our proof. Okay? There's a lot of different ways we can signify that we are done. I'm going to use these two lines like that, kind of like the parallel line symbol. This is a symbol that mathematicians use to show that the proof is completed. We have said what we started out to say. Okay, let's try another one or two. Okay, so we are going to do some of these. You'll notice in every one of these that I've worked out all the equations for you. We just have to be able to give reasons. And so you're always going to be filling in those reasons from these properties on this worksheet. Okay, on these notes where you're going to use those properties. So let's do another one or two together. All right, you'll notice this is the given equation we start with. A over negative 6, all plus 2 equals 5. That's given. Then we jump to this equation. Well, you can clearly see that we have subtracted 2 from both sides to get this. So that is the subtraction property of equality. And then from here to here, we would multiply both sides by that negative 6. So that's the multiplication property of equality. Okay? Why don't you pause the video and try and do some more of these. This section 3 through 5, you need to have done when you come to class. All right? To the best of your ability. We'll go over those together, but if you need any help, you're going to want to get that in class. But try and do as much of this as you can. You're filling in the reasons for these statements. We will check those together in class. All right, let's keep going just a little bit further. Now we're going to do some of these where we get to show the work ourselves. Now, I've given you 4 blanks for every one of these. There are so many different ways to solve equations that one of you might take 2 steps, another one of you might take all 4. It just depends. I'm going to have you follow along with me, even if you would take different steps on your own solving these equations. I want you to follow along with the steps I show. All right? So we always want to start by writing the given statement. And the reason for that is that it is given. Okay? And then we want to think about what would I do next. Well, most of you would recognize we should subtract 1 from both sides. Now, this is the one chance I'm going to give you to not show this step. We're not going to show the -1. If we do, I'm going to keep it written really small right here in the same step. I'm not going to write it in the next line. Okay, but you don't have to write that. That's why I wrote it in a different color. Okay, we're going to write what we would get. If I subtract 1 from both sides, this side is now just 3x, and this side is -15. And then my reason explains what I did. I subtracted from both sides, so it's the subtraction property of equality. Okay? Then again, the next step would be to divide by 3 on both sides. I don't need to show that. Okay, if you were really used to showing that step, you can put it like that, but it's not taking up the next line. The next line is where I write what I got by division. X is now by itself, and -15 divided by 3 is -5. And that was the division property of equality. Now, you'll notice that my last statement is what we set out to prove, so I can show that I'm done. Okay, I can show that symbol to mark that I've finished the proof. Okay? All right, once again, I'm going to allow you to try and do these on your own. At the very least, you need to solve the equation. You need to do the statements part. If you're not sure about the reasons, at least get the statements filled in before class so that we can come in and do some of the reasons ourselves. They shouldn't take you too long. If you're stuck on any of this, on solving the equations, feel free to just bring those to class and we'll talk about them then. All right, but that's how you do an algebraic proof. You solve the equation and you justify your reasons in the reasons column. This is our first introduction to proofs. They will get a little bit more complicated, but I think you guys will all do just fine. I'm ready to talk about this in class.